Hi, my name is Amit, and in today's session I will be dealing with another chapter from arithmetic from the chapter number systems, change of base. This is a chapter that you have likely to have done sometime back in your life, and this deals with decimal numbers, binary numbers, penta, hexa, octa kind of numbers, and how do you convert from one base to another. Okay, so to start off this chapter, let me quickly explain to you why is the decimal number called the decimal number. Okay, our number systems is called as the decimal number, and it is not because of the dot that you place if you're trying to write 37.75. It probably the dot has got nothing to do with the word decimal. Decimal is the meaning, the word decimal is derived from the word 10, and 10 means the numbers 0 to 9. Because we have 10 different digits, that is 0, 1 to 9, this number system is called as the decimal number system. What could be the other number systems? If you have a number system which only has 2 digits, for example 0 and 1, then it would be called as the binary number system or base 2. Now, in any number system, the numbers would start with 0, and then it would be based upon what number system are we talking about. For example, in base 5, there would be 5 digits starting from 0. So 0, 1, 2, 3 and 4. In a number system 5, there is no digit called as 5. In a number system 10, there is no digit called as 10. 10 is a derivation of 2 of the digits which already exist. Okay. Now, a simple concept, please try and understand. In our number systems, which is the decimal number system, we start writing from 0, 1 onwards and we reach 9. This is our number systems, 10 digits. What do we do after we reach 9? After we reach 9, we take the 2-digit numbers that can be formed using these 10 digits, and we start off with the smallest possible 2-digit number which can be created. The smallest possible 2-digit number which can be created using the digits 0 to 9 is 10. Then we increase the scale of this until we exhaust all 2-digit numbers. So we will go on to 11, we will go on to 12 and so on until we reach 20, 21, 30, etc. We continue until we reach 99. Once we have reached 99, which is the last possible 2-digit number that can be created, the largest possible 2-digit number, then we have exhausted 2-digit numbers. We then have to move on to 3-digit numbers. So again, the concept is very similar. We start off with the smallest possible 3-digit number using the digits 0 to 9. So we would start off with 100. Alright. How do you convert a particular number which is given, let's say, in decimal system to some other base? Okay. Let's take the number 45. This is in the decimal number system, which is the 0 to 9. So there could have been 9 digits in this. So this is the number in the decimal system, and I would like to convert this into base 4. Mind you, base 4 would have 4 digits, 0, 1, 2 and 3. How do you convert this into base 4? What you do is, you keep dividing this number by 4 and keep a track of the remainder. So I divide this number by 4. So I get it 4 11s are 44 and the remainder is 1. I again now divide this number by 4. 2s are 8 and the remainder is 3. Now, after this number cannot be further divided by 4, we stop. And the answer is looking at the remainders in the reverse order. So the remainders are 2, 3, 1, 2, 3, 1. So 45 of base 10 in base 4 would be written as 2, 3, 1. Writing it in this fashion signifies that this is base 4. Any number system, you could probably use it as a practice. If you're writing it in any other base, please try and write the base in this fashion. And in the decimal number system, while we are supposed to write 10, if you do not write it, that means that by default it is the decimal number system. Okay. How do we convert the base 4 number or base 5 number into a decimal number system? Let's look at a number. Let's assume that this number system is in base 5. We have to convert this into base 10. How do we do this? Very, very simple. Write the number in its scientific form. Okay? Scientific form would mean this number occupies 5 power 0th, because this is base 5, so 5 power 0th, and the value of this is 5 power 0th into the digit 1. This would be the next place, which is 5 power 1 into the digit 2, and this number would be 5 power 2, 0, 1, 2 into the digit 3. Now let's calculate the values. 5 power 0 would be, anything power 0 is 1, 1 into 1 is 1. 5 power 1 is 5, 5 into 2 is 10. 5 power 2 is 25, 25 into 3 is 75. Adding all these things up, 75 plus 10, 85 plus 1, 86. We can conclude that 321 of the base 5 is 86 in the base 10. Okay. Now I will try and explain to you the meaning of this particular structure of writing. But please understand this, that if it was some other base, suppose if you were dealing with 321 in the base of 7, then instead of 5 power 0, 5 power 1, 5 power 2, etc., you would be writing 7 power 0, 7 power 1 and 7 power 2. Why do we do this? Let's understand this from the decimal number system. Let's take our ordinary number 365 of base 10. Can I write 365 in this scientific form to try and find out the value? It can be written as 300 plus 60 plus 5. Okay, 365. 300 can be written as 3 into 10 squared plus 60 can be written as 6 into 10 power 1, and 5 can be written as 5 into 10 power 0. 10 power 0 is 1. 1 into 5 would give you 5. This is the scientific form of writing a number, and this gives you the value of the number. So in any other base, the way to write any number would be in its scientific form to find out the value in the decimal number system. Okay, so this gives you more or less the concept that you require to solve change of base type of questions. Suppose if there is a question that you have which is convert from base 5 to base 3, how would you do it? Do not try and directly convert. First convert the base 5 number into a decimal number system, and then from the decimal number system convert it into base 3. You will be able to solve the question. Okay, so We will now try and solve a few questions in this particular chapter.